Yes, I've made you the presenter. You have to click show my screen. Amit?
Sir, I will click.
Yeah, now we can see your screen. And so we are ready to start. And thank you all for everybody for attending. And thank you, Professor Tigara, for doing this webinar for us. Very interesting topic on activity-based programming learning. So over to you, Samit Latikara from Marwadi Education Foundation. Go ahead, please.
Hello everyone. Today I'm going to discuss something about activity-based programming learning. Ideally, it's suitable for all engineering students because everywhere in all discipline in first year we are having one computer-related subject, basically computer programming, and majority of us are focusing about C language. I want to begin with a learning pyramid. You all are aware that delivering in terms of monotonous lecture, student can retain only 5%. I'm sharing statistics from national training laboratories. Whatever they are reading, they can take it up to 10%. In form of audiovisual, they can gain knowledge up to 20%. Similar way through demonstration 30%, through discussion 50%. If they do a practice, then they can retain up to 75, and if they participate and if they teach others, then this ratio is above 90%. So my today's topic is related to this learning pyramid. How can we involve students in set of activities during their regular learning, specifically learning of programming? If we compare two learning patterns, passive learning and active learning. Passive learning is basically a teacher-centric approach where ideally teacher are delivering a lecture and students are ideally listening the same way. On the opposite one, if we focus on active learning, then this active learning pattern focuses more on student-centric approach where faculty is playing a role of facilitator and students are involving themselves in ongoing activities. If I talk about the outcomes, then in passive learning, ideally students are passive, while in active, students are active. In passive, as students are not taking part, it's more likely to be a disengaged environment, while in case of active, they are engaged one. In passive, disempowered, they may feel bored, unmotivated, while in case of active learning, they are empowered, excited, motivated. And above this all, in passive learning, basically result shows they are taking a superficial understanding of a topic, while in case of active learning, as they have been involved in set of various activities in a session, they are having a deep conceptual understanding of the topic. If I focus about programming, then programming is a foundation for any computer engineer specifically. They require a very good technical skills to gain a successful career. If I talk about various activities which you can consider in our regular teaching, wherever then activities, I'll go to each activity one by one. I already practiced these all activities in my last semester. I'll be happy to share result with you. I will also show you some demo activities, how they perform, statistics, various tools which are required of today's webinar. If I start with set of activities, then I've identified activities like MCQs, find the word, crossword, code magnet, half cooking code, long exercise, pool puzzle, troubleshooting, predict the output, match two sites, mini project, flowchart, algorithm, program activities, presentation, and open-ended questions. Now, if I talk about programming, let me give an example of C programming language. Generally, everyone is starting a C programming language with set of keywords. Traditionally, we can display set of keywords over a PPT. For example, if you are having 32 keywords, we can display all 32 keywords in a PPT. Student can read all keywords and they can memorize. They can focus on remembering part. So what happens over a period of time, they may forget important keywords. So my first activity which I am proposing is based on that find the word. So here all characters are jumbled. Through these activities, we can ask students to find out as many keywords as possible. So if we give such kind of jumbled characters in form of activity sheet, and if we can ask students to find out as many keywords as possible, then definitely students will engage themselves thoroughly in this activity. As a result, keyword from this sheet, then definitely they
Amit, I think some audio. We are not able to hear a microphone that clearly sometimes. Hello, Amit.
simple example yes sir.
I think your audio is breaking up sometimes. Maybe I don't know what the reason, but maybe stay close to your microphone. That is better. Okay. Yeah.
Okay sir. Okay sir. So this is the first key activity, find the word. Second activity which I am proposing now, that is a crossword. We all are familiar about this kind of activities. In schooling days, we have participated in such kind of activities. But now a question to engage students in such kind of activities. So this is a second one. If we give such kind of activity sets in routine, in classroom, and if we can ask students to participate in this activity, then impact will be the different one. As an example, this is a crossword related to string handling functions. So once we explain a string handling function, we can try to know programs. Now each question is having its own importance. Simple solution which we can focus at the end of activity. Half cooking code. Later on, generally what happens in traditional papers, we are asking students to write a complete program. So what is happening most of the time, they are focusing on mugging part. They are mugging the code. Instead of that, what we can do, we can involve students to focus more on logical part. We can engage as an example, in this half cooking code, we want to check whether number is an odd number or even number. So instead of asking student to write a whole program, let's focus our area on a main logic through which we can conclude whether number is odd or even. Simple solution, if number is divisible by 2, number is even number, elsewhere number is odd number. So here in half cooking code, we can provide a basic code. For example, we can provide a ready-made code to the students up to accepting number from the user. So here in line number 8, scanf statement is exist. So we can give code up to this scanf statement. Now student has to write a main logic to check whether number is odd or even. So this activity is basically focuses on half cooking code. Half of the code is already provided. Expectation from student is to complete the remaining code. This is a simple solution which we can focus at end. Next is pool puzzle. This is an interesting activity where student has to complete the code. How it differs from half cooking code? In half cooking code, they have to write a complete statement. While in pool puzzle, we are focusing more on very important aspects of programming. As an example, most of the students are making a mistake in scanf statement. Like here in scanf, given scanf percentage d and blank space. Now student has to fill this blank space. So actually this is a program to find addition and subtraction of given numbers based on choice. So in this program, all important words missing. That set of important words are provided separately in this table along with additional words which may confuse them. Here, student has to complete this code. For example, void, the next void, main is coming. So student has to pick main from this table and student has to provide main here. I'm going a little bit technical now, on technical track now. Similarly, here scanf percentage d, then here user is to accept choice whether the user wants to perform addition or subtraction. So for this, student has to select what to do. Here set of variables are provided like ch, no1, and no2. So student has to pick a proper variable. So here student will get %ch as one of the option, and from this place student has to provide %ch here. Similar way, here this is provided means here switch is required. So student has to switch from this place and student has to place it here. And various cases. So here student is to write S, then 1, then 2. Then important part in switch is use of break. So here student has to write break. This is a sample sheet. After putting all words, still around 5 words left in provided table. So this activity will help students to make a fundamental strong. Similar with code magnet, it is a lightweight activity as compared to a pool puzzle. How it is a lightweight activity? In this activity, we can provide exact number of words which are required to complete this program. While in case of previous, that was a pool puzzle, it is required to provide additional words that may confuse the students at the time of picking a correct word. So in this net, to complete the program, basically it's a program to print 1 to 10 on screen. So here, for keyword is already provided. So in 4, important part is how to initialize a loop, how to provide a condition, to provide exact number of iterations and alteration. So these 3 parts are very important. So here student has to pick a correct word from this given set of words and student has to complete this program. So for counter is equal to 1, counter is less than or equivalent to 10, counter plus plus. So here already variable is provided, that is counter. So student is to select that appropriate variable here, inclusion of header file and main. So it's a simple solution for code magnet. Next is troubleshooting. In this activity, we can provide a code with errors. This activity we can provide either in piece of paper or directly we can provide this code in form of soft copy to student, and we can ask students to make it correct one. So here statements are provided with errors. Student has to read this program thoroughly. Troubleshoot this program means they have to identify errors if any. Not only this, they have to correct the identified errors. It's all about troubleshooting. For example, if we take part in such kind of activity, we understand that, for example, here in void main, M is capital. Similar way, here in stdio.h and conio.h, wrong brackets are used. Angular brackets required. Similar way, here in printf, percentage instead of capital D, small d is required.
You're breaking up again. Amit, you're breaking up. Your voice is not heard. Some problem with the audio.
Please predict the output.
The microphone. Check. Can you connect the check with the speaker connection?
I will check, sir. Now is it okay?
Yeah, it's a little better. Yeah, it's breaking up now. Go ahead. Yeah.
Yeah. So here in predict the output, we are providing a complicated code. Student has to check an individual statement of whole program. After checking individual statements, they have to predict an output. So this kind of activity helps students at the time of placement interviews. Generally in placement, initial rounds focuses on such kind of activities which we can consider throughout a semester in regular sessions. Match two sides, a very interesting activity where we can provide set of statements with its answers and jumbled on both sides, and they have to pick a correct one. So it's a very interesting activity suitable for topics like whenever we are discussing data types, whenever we are discussing ASCII charts. At that time, if we introduce such kind of activity, definitely it will help students to understand the concept thoroughly. Program analysis. Whenever we are discussing a program, at that time, if we specify importance of each and every statement, then definitely it will provide a good impact on student. For example, in industry, if they want to include a particular logic or a particular statement, then documentation is required. Why it is important? Reason for that is, if they left in future and if someone else join, then easily that person gets familiar with the written code. So in this program analysis, we can provide a code like this and we can ask students to justify what is a requirement of a particular statement, why that statement is used in program. Is there any alternative? If yes, then what are the alternatives? So in this activity, they will justify each and every statement. We can ask even a student to write one program of their own choice with analysis of each and every individual statement. So this activity will help students to frame a very good and professional computer program. Long exercise. In this activity, generally if I talk about first year computer programming subject, then in first year, before starting any of the program, we are focusing on its graphical representation as well as step-by-step instructions, which we are referring to as flowchart and algorithm respectively. So here in this long exercise, we can provide one definition to student. Based on provided definition, we can ask them to first flowchart, that is a graphical representation of program. Based on flowchart, we can ask them to derive its algorithm. So algorithm is in non-technical form of statements, and based on algorithm, we can ask them to write a computer program. So here it is again a simple definition to check whether number is odd or even. So first to go like this. Based on flowchart, we'll write step by step to write a correct program. Based on this algorithm, ultimately they will write a complete computer program. So through this activity, it's possible to link all three components of a program together, like a flowchart, algorithm, and program. Through flowchart, they can build their logic. So if they are facing any kind of technical problems to write a correct program, then flowchart will help them to build a logic, because no technical terms engaged in a flowchart. Then based on flowchart, easily they can derive an algorithm. Once algorithm is ready, they have to map every statement with a technical statement. In this example, I have taken C programming language. So in phase 3, where they are writing a program, they require technical understanding of C programming language. These are the set of activities. Now, at the same time, how we can relate it with assessment. So if we are having an autonomy to award a grade to a student, then definitely we can take a maximum advantage from this set of activities. What currently I am focusing, how I have introduced these all activities to students in a regular curriculum. As a case study, I am showing you my pattern which I have followed at Marwadi University. Being a university, we are having autonomy to frame a syllabus as well as to deliver a content as well as to conduct an examinations and to award a grade. So I have taken a full advantage of this autonomy, and what I did is, first change is, instead of asking students to be in a traditional classroom, in this subject I have asked students to come in a computer laboratory throughout a semester. So instead of sitting in traditional classroom and instead of watching how to write a program, they have been engaged in actual computer laboratory and they have been engaged to write actual C programs. So instead of observation, I have focused on practice part. Because traditional teaching scheme focuses on 302, something like 3 hours theory, 2 hours practicals. Instead of that, I have considered all 6 hours, 2 hours, 2 hours, 2 hours, all 6 hours in computer labs. Assessments. Why assessment is required? Because ultimately it helps us to measure a student's learning outcome. We are going to assess whom? Students. When? During each session or at once in every 3 weeks. Depends how kind of assessment pattern we are designing. In my case, I have taken a latter approach. I have engaged students in routine activities in each session, but for grade I choose it once in every 3 weeks. Where in computer labs? How? Through participation in session as well as activities and learning management system. So I'm just sharing first my assessment pattern, then I will discuss about that simple paper and tools. So here I have to evaluate various components like semester examinations, mid-semester examinations, internal, Viva and homework. So what I did as far as semester examination is concerned, I removed a traditional exam which is likely to have at end of semester a traditional 3 hours question paper. Instead of them, what I did, I have engaged students throughout a semester and I have adopted a methodology like continuous assessment. So instead of taking end semester exam at end of semester only once, I have involved students in set of activities what I have described earlier. Based on activities, I have given final grades. So as far as end semester examination is concerned, I've identified a set of activities from the discussed one like half cooking code, long exercise, predict an output, analysis, full puzzle, open-ended questions. As far as mid-semester examination is concerned, what I did,
Lost you again, Amit. Something is happening with your audio once in a way. We've lost your audio, Amit. Please check.
the if statement. These all MCQs I've designed as per the patterns adopted by industries at the time of placement interviews. So benefit is during a regular study, students have gained an experience about what kind of questions various industries are asking in routine placement activities. So I evaluated this component through MCQ activity which I discussed earlier. As far as internal component is concerned, what I did, I've involved students in set of lightweight activities like a crossword, find the word, chord magnet, troubleshooting, match two sides, flowcharts, and algorithms. As
Again,
far
we've
as
lost you.
YY is concerned, traditional set of question and answer session at end of semester. As far as term work is concerned, set of activities. Here I'm focusing on project and project based learning. Brainstorming sessions introduced at beginning of course. Students have participated in these brainstorming activities. They've identified one problem. This is what I'm talking about beginning of semester. At week 2, students have identified set of problems. We have verified all those problems and students have started their project work. We have specified these term work components with set of headings like definition and project description up to the mark, then 5 marks, flow and quality of code 5 marks, progress and continuity of project 10 marks, presentation 5 marks. For individual head, set of well-defined rubrics specified and shared with students. So here project-based learning also introduced. Throughout a semester, student has worked on a particular project. At end of semester, student has submitted that particular project. Topic wise methodology also specified, like in which topic which kind of activity is suitable. For example, C programming basics, crossword, word finder, match to sites, MCQs, predict the output. Similar way in control structure and looping, set of activities, array and string, set of activities, and pointer, set of activities, dynamic memory allocation, again set of activities, file management, a long exercise, structure and union long exercise, and data structure using C, set of activities. Now what sharing? I'm sharing with you various statistics and students experience, student feedback. So let me share it with you. First, what I'm showing you is what kind of activity sheets I've designed. Is a demonstration sharing with you one sheet. Like on one day, students have participated in such kind of activities like find and solve errors, kind of troubleshooting. They have to identify errors. Not only this, student has to rectify that error. Then activity related to puzzle, match two sites. It's all about a string and crossword. This is another sheet I'm sharing with you. I've engaged with them with set of activities like cooking code, where I've given a basic code. I'm expecting student to write the remaining code. Similar way, troubleshooting, where they have to troubleshoot a code, you have to write a new code, puzzle, match two sites, and output. Sharing with you sample sheets, half cooking code, troubleshooting, where you have to identify errors with specific line numbers. They have to write a new code, puzzle, chord magnet, two sides, predict an output. Even you can do all activities using a computer, or we can circulate sheet like this. I'm sharing their participation. For example, find and solve errors, where student is to highlight error and they will write a new code after troubleshooting the code and after removing all errors. Similar way, this is full puzzle, match two sides, and crossword. I'm sharing one more sheet with you. Half cooking code, line by line troubleshooting, full puzzle, match two sides, predict an output. As far as MCQs are concerned, I've used a tool named as Socrative. Through a Socrative, we can engage a student. What I did using a Socrative, in a Socrative, I've created a virtual class. At end of every unit, I am checking a knowledge of student. For an example, this is a sheet of a student. Sample sheet I have uploaded in Socrative, where I have specified set of questions. For example, at end of arrays and strings, I have framed set of questions where they have to write a single liner question, which is of course not focusing on remembering part, but they have to build a logic. For an example, write a C statement to initialize an array of 5 numbers like this. Given, use array name as no, type as int. It is required to provide an accurate information Reason for this is on behalf of us. Tool is evaluating a student. So here Socrates will assess all individual sheets of students. So if there is a mismatch of even a single character, we may get something different in result. So that's why we
So
have
tell
to
me,
provide.
yes, can you tell us what is Socrative? Can you
Yes,
explain
sir.
what is Socrative?
Socrates. Yeah, Socrative is a software. It's a kind of a software which we can consider as a pointers. What exactly it is, I'm sharing with you. In Socrative, we have to log in as a teacher. We can frame a virtual classroom. In a free version, it gives a classroom capacity of 50 at a time, meaning we can engage a 50 students. From here, we can launch a quiz. Before launching a quiz, we have to upload a quiz. So this is the same quiz which I have demonstrated earlier. So I have framed all questions here. You can ask students to join a Socrative.
Good.
Join a Socrative. I'm just giving you a demonstration because it's a very interesting tool to engage students.
Very good. I didn't know that. Good.
Quiz, whatever you frame. For example, I'm launching this quiz.
Yeah.
So as soon as I start from this panel, student will get immediate response like this. For example, array is a collection of elements having dissimilar type, true, false. Let me choose a false, submit an answer. If it is wrong, it gives a correct one. Just randomly I'm giving answers.
Very good.
Benefit there is, as soon as students are participating on teacher console, on teacher dashboard, we can identify each and every activity. For example, student wise, question wise. At end, one student finish this quiz, at end will get a detailed report. So at end of every unit,
Okay.
we've used a Socrative to collect feedback from a student, what they understood through a set of activities. So this is a sample sheet and it gives.
Good. Couple of questions have come. One is, does Socrative work like Edmudo and some other LMS?
It is not LMS. Socrative is a kind of a clicker software. Through a Socrative, we can take responses like this, but it is not LMS. If you want to go for LMS, then we are having various options like Edmudo or a Canvas.
Okay. Okay. Another question, which one is better, flowchart or algorithm for non-IT students?
Yeah, for a non-IT students, they have to begin from a flowchart first because in a flowchart, students can define a logic very well. In a flowchart, we do not require any kind of technical knowledge. They have to build a logic to solve a problem through a various symbols. So first step is obviously a flowchart. Once a flowchart is ready, using a flowchart, you can derive an algorithm. Again, algorithm is comes under a non-technical category. They have to write English like statements to solve a problem. Once a flowchart and algorithm is ready, next step is to write a program. So for interdisciplinary projects, non-IT students can work on flowchart and algorithm. and a team member who is from IT background can take a ready-made input from provided flowchart and algorithm.
Okay. General question: how many students are in your class, and how many times have you taught this course in this manner?
Yeah, in my class strength is 60, but I splitted my class in two groups as I'm engaging them in computer laboratories through set of activities. So I kept my class size 30. Total class size is 60. I split it in two batches.
Mhm.
As far as this course is concerned, I'm taking this course since 2005.
Mhm. Now, how many other sections of this course, and somebody else must be teaching the same course, right?
As far as this course is concerned, I've splitted my class in two batches and I am responsible for both batches.
Also, only 60 students overall take C programming?
Yeah, agreed. For remaining classes, we are having a different set of faculties. So here we are having a concept of subject coordinator. So we all are sitting together and we are deciding a common frame sets, common frameworks, common set of activities, and we all are engaging students on a common platform and with a single environment.
So how many students overall are taking C programming in 1 year?
Overall, if I am talking about this course, then last semester 180 students have taken this course.
So that means there are 3 faculty members are teaching 60 students each?
Yeah, agreed, sir. 3 faculty members and 60 in each.
And are they all following the same approach, or only you?
Same approach, sir.
Mhm.
Same
So,
approach, same set of activities.
so how do you know these various activities that you're doing are effective? How do you know they're working?
Yeah, agreed. So for that, I'm showing next one.
Yeah.
In this operative, and you get directly a result like this, a summary sheet of each and every student. We can judge what is right, what is wrong. If it is wrong, then how can we make it correct one so that they can use it in next activities. At the same time, Socrates gives sheet of individual students. For example, the sheet of one student named as Anil Malak. So we can identify in which part student is weak and on which part student is strong. So this is benefit of Socrates. Next is about effectiveness. What I'm doing now is I'm sharing activity-based result. For example, given MCQs end of every session. So this effectiveness, easily we can identify what is a result. This we can identify what is the result. Majority of
Okay.
the
So,
students
yeah.
are above 60-65% of score. This is for one activity.
Yeah.
Now
So,
what I'm doing,
yeah.
in general, I'm sharing with you.
Mhm.
I will remove name for time being, and I will kept serial number. This is a set of activities. When we have introduced this course without any activities, at that time, result was approximately 35%. In this semester, through these activities, my result is 66.86%.
Very good. Very good. Mhm.
So this is overall sheet, individual activity wise
Mhm.
marks.
So
And
what is the ideal classroom strength? Your thinks 30 is your ideal classroom strength?
actually, ideal classroom, if we talk about ideal classroom, as we are engaging students in set of activities like this, if classroom size is smaller, then we can give individual attention to each and every student in each and every activity. So ideal classroom strength is 30. We can stretch it up to 45. But personally, I am not advising to go beyond 45.
Okay, can we allow students to bring their own devices, like, or is it only
That is
possible inside
possible.
computer?
Yeah, that is possible. Students are bringing their own devices. They are free to bring laptops within the computer labs.
Okay, very
And
good.
we have focused on open source technologies instead of running this course on proprietary softwares. We have used open source softwares. We have used Ubuntu in lab as an operating system, and we have asked students to work on GCC as far as the C programming is concerned.
Good. Very good. So any other questions? I'm going to ask the participants if there are any other questions, because we'll run out of time soon.
Yeah,
Participants,
last I'm sharing.
they have been asking questions. Yeah.
A course of feedback. Again, through speculative, and I've asked students to specify various things about this course, like 3 points that they're liking about this course, 3 points which they are not liking, gained any knowledge, was learning environment joyful, 3 points about activities which they like most, which they don't like most, any other comments, topics which they are thinking that if it is a part of curriculum, it is a good one. So I'm sharing the result with you. This feedback also I've taken anonymously. Purpose of this feedback is to check whether whatever activities are proposed, whether they matched with objectives and learning outcomes or not. Almost everywhere students have
Very good. Excellent presentation, Amit. That was very nicely done. Very nice examples of active learning and how that is improving the actual performance by the students. One last question has come, but it is, can we allow students to take test quizzes from their home at a convenient time?
that is possible. That is possible if we launch a quiz and if we keep that quiz open for a particular time, then it is possible that students can give quiz through their own place. What I practiced, I have conducted all quizzes, that is a kind of MCQs within the lab. If student is present in the lab, then only then student is in a position to attempt the quiz.
Very good. Excellent. So you have given some
Motivates students. Basically, it motivates students to be in a classroom.
Yeah. So some of the participants are saying excellent job. Thanks, Amit, Socrative. Okay. Thanks to Amit. So good. Yeah, you have given people a lot of ideas how they can improve their the classroom for C programming. So I really appreciate that, and thank you for taking the initiative. So
Yeah, most welcome, sir.
On that note, I want to thank everybody, and I see no more questions. So that is good. That is thank you so much, Amit, and appreciate it. Okay, so we will be in touch.
Thank you. Sure, sir.
Anybody have any questions? Please feel free to send to this email ID and mobile number that Dr. Amit Latigara has provided. Okay, and let's all give Amit a big round of applause. And people are saying best presentation. There are people here saying excellent, best presentation, very nicely done, good. Even a little bit of audio there sometimes was there, but otherwise it was very good. Thank you so much, and Jai Ho.
Yeah, thank you, sir. Jai Ho.